Dwight.
And Mr. Rops.
We're going to do area between two curves, integrals. So basically what's going on here is we've got one curve on top. So we'll say that this one's y1. And one curve on the bottom. We'll say that this one's y2. Okay, and basically it's exactly what you would want to do. You want to find the intersection points first. So we'll say the intersection points are B and A. And then if you find the area, so the technique is you find the area of underneath y1, so that will be the integral from a to b of y1 dx, a to b. And then, so that will be this big area here. And then you literally take away the area underneath y2.
And so what you're left with is the part in between the two curves.
So a to b of y2 dx. Yeah, and you're left with this area right here. So that's about it. So the question is, does it work everywhere? Can I put it anywhere? So let's do a little example here. So just to reiterate, let's say that the area under y1 is 4. And the area under this whole thing is 4. And the area under y2 is 3. So that's 3. What would that area in between be?
Between has to be 1.
This guy will be 1. Okay? So if I get rid of some of this stuff, let's move our functions around. So if we grab this guy and we move him down here, now what's happening? Is it the same way? I don't know. We'll find out. So let's say that this, do we take the top one or the bottom one? That's the question. Which one do we put on top? So this one, we'll say, is the area under y1 again. So this is y1. So the integral from a to b, so the integral from a to b of y1 dx. And then we'll say that this one is -2. And then we do the integral from a to b of y2.
Which is the bottom curve again.
Which is the bottom curve again. We'll say that this is -3. So all the red there. So minus the integral of a to b of y2 dx equals, so that's -2 -3 minus -3, you subtract them, right? Minus -3, so minus -3. So -2 plus 3 is 1. It works. So it's always the top curve minus the bottom curve, no matter if it's above, below, quadrant, second quadrant, third quadrant, fourth, first, no matter what.
So it's always top curve minus the bottom curve.
Top one
even if it's below the axis.
That's pretty cool though.
That
Works
is
every
cool.
time. All right, so let's move on to an example. So we find the area of the region enclosed by this quadratic and y equals 3. So the first thing we need to do is find out when they're actually equal. So the first step is x squared minus 2x equals 3.
Let's bring all to one side so that equal to 0.
Everything equals 0. We can factor this.
It's so nice when they're nice numbers to factor.
Yeah, that is pretty nice. Minus plus equals 0. So it looks like they are equal at x equals -1 and 3. Okay.
Okay.
So here's something going on here, which maybe you don't know which one is on top.
That's a good point.
It's a good point. Actually, it doesn't even matter, because if I switched these back here, -3 minus -2, I'd get -1. You know that there can't be negative areas, so we just make it positive.
Make it positive.
All right, so let's go ahead and do this. We know that this one goes through 0, 0, so I'm pretty sure that this one's on top.
Right, of
Right.
course.
Okay, so let's do the integral from
-1 to 3.
-1 to 3 of
The top curve, which we figured out was,
top. Ooh,
top is 3,
top is 3.
because the x squared minus 2x goes through the origin.
Minus -1 to 3 of x squared minus 2x dx. You can obviously do this as one integral. You can break integrals up. I like to keep it like this because that's two terms you already got to deal with. Dealing with three terms in one it's a little much. All right, so let's do this. The integral of 3 is 3x from -1 to 3 minus the integral of x squared.
1/3 x cubed.
1/3 x cubed minus
X
squared from -1 to 3. Okay, so let's keep ourselves very organized here. We have 3 times 3 minus 3 times -1. Did I do that right, Mr. Ross?
Yep.
Minus, plug in 3 here, we get 27. Divide by 3 is 9.
So far, so good.
Minus, plug in 3, we get 9 again. Let's put that in parentheses. And then we subtract when we plug in -1. So -1 cubed is -1. Divide 3 is 1/3. Put your parentheses here because I'm going to distribute that negative.
A -1/3 because a -1 cubed is still negative.
Oh, -1/3. There we go. -1/3. Okay. And x plus 1. Correct?
Correct.
Okay. So let's organize. We're all organized, I think. So 9 plus 3 is 12. Minus, that's 0. Negative times a negative. So we have -1/3 minus 1. That's minus 2/3. No,
minus 4/3.
Minus 4/3. So that's minus times minus is plus, and this is a minus 4/3. So should be, no, that was right. Right? Minus 4/3.
Right, minus 4/3.
Minus 4/3. Okay, and then let's do a common denominator. So 36 over 3 minus 4 over 3.
32 over 3.
32 over 3 is our answer. So the area between these two curves is 32 over 3.
Sounds good.
Okay, so then we'll do this one on a separate podcast, so go watch that one next.